Hi there, my name is Patrick Pusher, Technical Evangelist at Orca Security, and it's time for another cloud security punch-out match between Orca Security and Rapid7 Insight VM. The Punch-Out series is a collection of competitive comparisons between Orca and other cloud security solutions. This comparison was done as of September 1st, 2020. If this is the first in the series that you've tuned into, our scenario is that we've got a basic lab that we've inherited from an acquisition we made of a company that leverages AWS. We know very little about the lab other than the lab diagram that's been provided. Our goal is to deploy both Orca and Rapid7 and point them at our cloud environment to determine what the biggest security risks are. So let's get to it. If you've tuned into the series before or are otherwise familiar with Orca, you will notice that the look and the feel of the product has changed. Welcome to our next generation user interface. Deploying Orca Security is very straightforward. Here are the steps. I've logged into my AWS account ahead of time, and so first I'm going to leverage the provided CloudFormation template to create the necessary role and policies that Orca requires. We're fast forwarding through the process to save time, but it's as easy as taking the generated Amazon resource name or ARN, pasting it in, and selecting Connect Account. Orca then verifies the permissions and begins scanning. Installation is a one and done process, meaning that from this point on, all resources that debut in our cloud account will be necessarily discovered and evaluated by Orca. Deployment with Rapid7 is significantly more involved. Like several of the platforms we've featured in the series, Rapid7 Insight VM is deployed with both agents and network scanners. This means that you install and maintain an agent on each workload that you wish to protect. What's different with Rapid7 though, is that if compliance is one of your goals, you must also deploy network scanners. That's right, the agent only delivers vulnerability information but not compliance, so you'll be installing and maintaining both agents and scanning appliances. In addition, the console is not provided as a SaaS offering, so you're also responsible for deploying and maintaining that. The good news for our small lab is that the console can also function as a scanner, so for our small deployment, we didn't have to deploy more infrastructure, but in a real-world scenario, you most certainly would. Sizing the Rapid7 console was challenging. I was confident we needed nothing more than the minimum requirements for our small lab, but I was wrong. I initially sized the instance that housed the console at 2 cores and 4 GB of RAM, a T2 medium AWS instance. Under that configuration, the console was very unresponsive, so I bumped that instance up to a T2 large, which is the same 2 vCPUs but with 8 GB of RAM. The system performed much better until I understood that I would also have to scan systems from the console as well if I didn't want to provision a net new scanning instance. Once I triggered a scan of even 4 workloads, the console would continuously pause my scans because of memory requirements. I finally upgraded my instance to a T2 extra large, which is 4 vCPUs and 16 GB of RAM, and had no more performance issues. The Rapid7 workload agents are downloaded and installed per resource. Installation is straightforward once you get the agents copied, but does require local administrator privileges on each system that you deploy. Rapid7 does not have a separate agent for containerized workloads. Rather, the native Linux agent is supposed to be able to understand containers. Although, and a bit of a spoiler alert here, we had significant challenges here. In order to report findings to the Rapid7 backend, these agents must be able to send traffic from each resource to the console, which is typical with agent deployments. What isn't typical is that with Rapid7 you deploy the console where you want, which can be right alongside your cloud infrastructure. Because of this, we had to make fewer changes to our environment to support the agent-based functionality than we did with other vendors with SaaS backends. Agent installation was straightforward for us in our modestly sized lab, but in the real world, agents represent a lot of effort to install and maintain, and at the same time, very poor overall coverage. As mentioned before, you would also have to deploy scanners per VPC if compliance is your goal. So, we've covered deployment, let's shift to findings. In terms of traditional vulnerability detection, Rapid7 did a good job of finding vulnerabilities across our 4 hosts that participated in the exercise. Our 5th machine is one that we do not have credentials for, so it was not able to be scanned by Rapid7. Insofar as the container in our lab, Rapid7 had a hard time detailing any information about it. To be fair, it is hosted on an Amazon Linux 2 workload which isn't officially supported by Rapid7. Rapid7 found vulnerabilities on that system itself, but wasn't able to understand the container. Rapid7 has a feature called Real Risk that takes the CVE score and considers additional factors like vulnerability, age and complexity, the existence of malware, and more. The context of cloud workloads is not considered, however, so the Rapid7 calculated risk score did little to separate what was exposed and truly risky versus what was tucked away and unreachable in my lab configuration. Labels like context-driven risk scores suggest that some of these factors are considered, but in reality, that context is derived from tags that administrators can manually apply to specific machines in Rapid7 to consider them more mission-critical than others. Rapid7 detected no malware in the lab, despite advertising the capability to do so. Insofar as compliance, the Rapid7 agent is not enough. To utilize any of the compliance features within Rapid7, you must deploy and leverage authenticated scanners. On AWS, this means you must have at least one scanner per VPC or maintain many VPC peering relationships. Rapid7 must ask for and store the credentials to each workload for compliance to function, which means one more vector of potential compromise. Once configured, Rapid7 did a better job than some other platforms we've seen matching up compliance standards to the appropriate hosts, although we did experience some problems here. Rapid7 mistakenly mapped the CIS Ubuntu 2004 standard to our lab, which isn't accurate. It also found reason to map the CIS Palo Alto firewall standard when we clearly didn't have such in our lab. We even scored over 75%. Mapping to the Docker standard was also missed, despite us having Docker installed, running, and hosting containers. Compliance scans are done via IP address, which in a modern cloud computing environment is very problematic. Resources come and go ephemerally, and IP addresses get continuously reused. The Amazon Web Services Asset Sync dynamic discovery capability in the product is supposed to assist here in the discovery of new EC2 instances and pruning of old ones, but scans are still defined by IP address. Lastly, Rapid7 have good support across many standards, including CIS, DISA, PCI, and HIPAA. Rapid7 has a cloud configuration capability that performs CSPM types of tests at the cloud control plane level. It includes tests across EC2, CloudTrail, CloudWatch, S3, and more. Although not a full CSPM, this capability found our S3 bucket as both publicly readable and writable, something that most CSPMs haven't been great at thus far in our Punch-Out series comparisons. We're still disappointed with what is considered critical and severe out of the CSPM tests, but this is more of an industry problem than one associated specifically with Rapid7. The cloud configuration feature does not support compliance standards. Shifting our focus over to Orca, let's take a look at our findings here. We can review our alerts on the dashboard, but let's navigate to the Alerts tab. And right away, we can see that Orca found malware in the container, on the host that runs the container, and on our internal Windows management server. If we dive a little bit deeper into our container, we can see that we also have a service vulnerability to do with SSH. You can see that Orca rolls up CVE findings on the left, and instead of inundating you with individual alerts, Orca has aggregated them and presented them as a group. So if I update SSH, I will take care of over 80 individual CVEs. Scrolling down to the attack vector, we're reminded that this container is directly internet facing, which is why this alert is risked as hazardous. We also see some observations around non-compute resources as well, like our publicly readable and writable S3 bucket. We also found some unsupported host OS alerts, all for workloads based on Ubuntu 14.04. We found passwords and shell history, which is a significant risk from a lateral movement perspective, among other things. We also show you what commands can be used to harvest this information, and of course recommendations for remediation. We also found AWS keys in what appeared to be a configuration file, again, disastrous from a lateral or perhaps a vertical movement perspective. Orca tells you where they were found on disk and which user and account they belong to. Just like with the passwords and shell history alert, I also see how these credentials can be harvested within the simulation command section. In the same preventing lateral movement bucket, we also found insecure private SSH keys. But you'll also notice that since Orca has perspective over your whole cloud estate, it has mapped out the systems that the keys provide access to. We found weak host passwords, which means commonly used passwords are those found in published breach account information. A quick look at login attempts, and I can tell that logins are definitely being attempted from the outside when this machine's been exposed. We've also got an unpatched host OS alert, which is another great example of a roll-up of vulnerabilities, in this case over 600 of them. Orca has risked this alert as hazardous, even though it does not have inbound connectivity. Why? A quick stop at the attack vector map and you can see that moving laterally from one of our other resources that is internet facing, namely from XYZ container host, is possible. So let's summarize. As we mentioned, both Orca and Rapid7 were able to tell us that our S3 bucket was both publicly readable and writable. Orca was able to find malware in 3 locations where Rapid7 found none. Both Orca and Rapid7 were able to tell us about unsupported operating systems, but Orca advised us of 2 more than Rapid7 did due to the fact that both our container is based on old Ubuntu release, as is our workload that we don't have credentials for. Rapid7 wasn't able to tell us anything about our container at all. Only Orca alerted us regarding discovered passwords in shell history, insecure private SSH keys and the systems they provide access to, unpatched operating systems and software with CVE rollups, sensitive AWS keys and the accounts they map to, and weak host passwords. Taking a step back, Orca was deployed once and in only a few minutes, whereas Rapid7 is installed both per asset, meaning that each resource you wish to protect requires agent installation and is in competition alongside your applications for precious CPU, disk, and memory resources, and per network with scanner deployments if compliance is one of your goals. Both platforms did a good job of host vulnerability detection, but we gave Rapid7 half a point in host-based compliance for 3 reasons. 1, I have to deploy a lot of additional software and infrastructure. 2, I couldn't get the scan engine to scan Windows workloads for compliance even with the proper credentials in the credential store and following the documentation regarding ports that I had to have opened. And 3, for the many mistakes made in mapping compliance standards to our workloads. Compliance at Orca is undergoing major change. You can still find those same reliable results in aggregate using the main menu compliance navigation, but it's the only portion of the product that hasn't quite been updated to the version 2 UI. We're currently re-releasing per resource compliance under the new UI, so please watch this space for new functionality coming very, very soon. Rapid7 has limited capability for cloud plane tests as well, measuring services such as IAM, EC2, and S3 bucket security. And the results were accurate, but support for compliance standards don't exist. As we've mentioned already, Rapid7 wasn't able to detect any of the malware present in our lab. Only Orca is able to gather all of this intelligence with no impact to workloads at all, even when resources are stopped. How? Orca is able to determine this information in 2 ways. The first is the process of side scanning, where Orca analyzes the storage that powers your workloads in an out-of-band fashion. And the second, a healthy dose of context, a mixture of that data-driven intelligence with cloud control plane measurements, including security groups, route tables, IAM permissions, and much, much more.